Hello, everyone, and welcome to this course. I'm very excited to share some data science concepts with you, and the whole course is designed to be an absolute beginner-friendly course. So if you have no prior background of data science, math, coding, no problem, I've got you covered. So now let's look at what we have to cover and to set some expectations about this course. So what is the promise of this course? The course is for absolute beginners. As I said in the very beginning, if you have no prior background of any kind, machine learning, data science, and all these terms seem scary to you, and that is why you have been little reluctant to learn any data science course, this course is designed in a way that there is no prerequisite required of any kind. So no need to learn any programming, machine learning, nothing is required as a prerequisite. One thing which might be a little nice to have is that if you have dealt with Excels in your past, then that is definitely a little plus, because then you know how to look at the data. And even if you don't have it, that is absolutely fine. So the whole course is designed to be a very beginner-friendly. And if you are a little bit advanced, then maybe this course is not for you. So coming to where we will reach by the end of this course. So I've already established the start line. The start line is that if you even know nothing about data science, you can definitely take this course. Now, in terms of where we will reach by the end of this course, we will be reviewing and actually using some of the most popular data science libraries in Python. So we'll be looking at pandas and we'll be looking at scikit-learn. And then we will be doing an end-to-end actual real-life data science project where you would be analyzing an open source data, which is Black Friday sales data. So this is a sales data where you are provided some attributes and details about the customers and some attributes about the product which they have bought. And by looking at that, our job will be to predict that who is going to buy which product in future. Now, this is definitely a very exciting use case, because and use cases like this, they're like very common in marketing and in real life business settings, because businesses want to predict what is going to happen in future. And if you could have this kind of prediction ability, then that is definitely a great asset. And this project is definitely a very beginner friendly, and it is supposed to act like the first map which will give you an overview of how different components of data science are, how do they interact with each other. For example, how do you use pandas and how do you use scikit-learn and why do we use this and what is the purpose of that. So all those little scary terms, including linear regression and how do we do some analysis and exploratory data analysis, all of that we'll be covering in this video in a very beginner-friendly way. If you are actively looking for data science jobs, you might want to check my Data Science Accelerator program. This is an exclusive program where I select very few students and I work with them to help them land their first data science job or internship. And that is 100% guaranteed. If you get selected for the program, you will get 2 times weekly calls with me in a small group setting and a monthly one-on-one call with me as well. And I'll go over your resume, your LinkedIn, your cover letters, and I'll help you narrow down the scope of your applications to the companies which are most likely to respond back to you. And not only that, I'll assess the weak spots in your technical knowledge, and we'll do the mock interviews to make sure that you are fully prepared and confident when it comes to the interviews, and you have a very good chance of clearing those interviews. And the best part is that the entire program is on a pay-per-result basis, which means that after the program, if you still do not get a data science job, you will get your entire money back, which makes it a zero-risk decision for you. I work with very carefully selected, very few people. So if you are interested in learning more about the program, please check out the link in the description below. So in a nutshell, I've designed this course to be the first intro to data science, which I wished I had when I started my data science journey. And I'm very excited that if anyone who is in the same shoes this should definitely help them. So now let's go to a little bit intro of me. Why am I teaching you this? I'm also a data science student like you. Since you have started your data science journey, you are a data science student, and I'm just a data science student like you. It's just that my journey started a while back, a little over a decade ago. So I've been working as a data scientist in different US tech companies, some of the biggest names like Meta, Cisco, and I have been in the industry for 10 plus years. And currently I'm working as a senior staff data scientist. For people who are not familiar with this jargon, I just outlined that when you start your data science journey, your first job usually is that you become a junior data scientist. And after that, if you get promoted, then you become a data scientist. So now you are not a junior data scientist, you're actually a data scientist. And then you become a senior data scientist. And this is usually considered a terminal level. By that, it means that there are a lot of people who would stay on this level forever. And then if you get promoted, you become staff data scientist. And then a step after is senior staff data scientist. So that's what I have reached in the last 10 years. And during this journey, I've been part of many hiring committees in different companies I've worked in. And I've conducted, of course, many interviews. And I've been on both sides of the interview table. I've conducted a lot of candidate interviews, and I've been a candidate myself in a lot of interviews. And you name a big company, and I have given an interview for them. A lot of them I cleared, a lot of them I did not. But at least I have a very good idea of what is in demand in the data science job market. What do companies look for when they're looking for talent and skills? So all of that knowledge I've been sharing for the last year or more on my YouTube channel as well, where I have 4,500 plus subscribers. So this is a very long way of saying that I know a thing or two about data science, though I still consider myself to be a data science student. And I'll be sharing my knowledge, what I have acquired in the 10 plus years, in a way that if I had started my data science career in the very beginning, how I would explain that. And with that in mind, let's go to see that what we'll actually be covering throughout this setting. So we'll begin with just to give you an intro of data science. Now, if you're watching this course, you might already have a good idea what data science is. That is why probably you signed up for this course. But I still wanted to touch base on this very quickly because the definition of data science, it keeps changing. And even companies, when they're hiring for data scientists, they're not fully sure what they mean by data scientist. Some people think that data analyst is the same thing as data scientist. And there's a lot of confusion. What is AI engineer and what is machine learning engineer and what is data science? So we'll try to touch a little bit on that and share my perspective. Of course, there is no right answer for that. Second thing we'll cover is what is the future of data science. Now, again, my thoughts on this might be a little biased since this is the industry I've been working in for last many years, and this is the industry I love. So take it with a grain of salt. But as a data scientist, it is also part of my training to look at the data and carefully analyze it. So I'll share my thoughts on what I think the future of data science looks like, and should you actually be spending any time learning it or not. And then we'll go into Python. So this is like the actual meaty stuff where we'll actually do some hands-on exercises. And we'll be using Google Colab as an environment where we will be running the code. And these two are very lethal combination in terms of how easy they make the things. Then we'll be looking at Pandas, which is the first Python library, which we'll be exploring in detail. What is a library? I'll touch in a minute. But Pandas essentially is, you can think of it as an Excel in Python. So Pandas is basically Python's Excel. So the way you open something in Excel, you can do the same things in Pandas, but since it is programming oriented, it is much, much more powerful. How? You'll see it in a moment. Then we will be looking the library of choice for most thing machine learning. And by machine learning, I mean when we are trying to teach machines to do something, that is when machines are learning, and this is called machine learning. So a lot of the predictive power, it comes from machine learning algorithms, and scikit-learn, it was the library of choice. It still is one of the most popular library when it comes to making any predictions on the data. So we will be looking at that and actually making a very fun project. And just to highlight some things of housekeeping. First thing is that this course will be a little long. I just started it. I don't know how long it will be. It could be an hour to, I don't know. But it will be recorded in a single setting. And my expectations from you would also be that just take some time when you can go through the whole course in a single setting, because this is not, it's not like a very long course which you have to divide in chunks and you have to like spend a lot of your mental energy. I've tried to keep this course very easy to go through, and just whenever you have time, if you don't have time right now, you can just bookmark this, save this, and come back to this later. But any evening, any weekend, when you have some time to spare, then start this course. I think it is recorded in a very conversational, friendly tone, and I hope that if you just go through this course in a single setting, or maybe 2 or 3, not a hard and fast rule, but try to go through it in a longer settings. The second thing, as you can probably already see, that this course is like very minimally edited. I've tried to record it in a way that how would I explain data science to a friend, and because of that, it's recorded in a friendly way with minimal editing. I'll be stumbling, there'll be awkward pauses, I'll be looking for stuff in my laptop. So all of that is raw, unedited. So I hope you don't mind it, but that's how I am in real life. So you'll get a chance to see that. And so take it easy. I'm recording it in a very friendly and easy to consume way. And I hope it come across as is on the other side when you are watching it. The other thing, when I was planning to create this course, is that with this course material, you don't have to do any follow-along exercises or quizzes, or just go through it as if you are listening to a friend, and in a very easy to consume way. You don't have to take notes. You don't have to take screenshots. All the codes, all the slides, even the cheat sheets, which I'll be sharing in the description below. So all of that material will be provided to you. So just take a step back, take it easy, and try to consume this course in a very easy way. Don't spend a lot of mental like bandwidth on it, that you're trying to learn something which is very complicated. It's not rocket science. And I've tried to convey it in a way that it will actually come across as not a rocket science. If you want, you can watch the course at 2x speed, and anything which you do not understand, you can always come back. As I said, all the material of this course will be provided to you. It's for you to consume, even if you want to come back in a week or so. So take it easy. The other thing I want to say is that this course, as it is very beginner friendly, it's not covering everything. Of course, if you pick like anything, there is a lot of depth in everything. Not only data science, it applies to every aspect of life. But this course, I've tried to take the 80-20 rule to the next level. So this is more like 90-10 rule. And what does 90-10 rule actually means is that 90% of the results, they come from 10% of the input. So 90% of the time, people are using the same Python libraries. 90% of the time, within those libraries, they're using the same kind of commands. And those commands are actually just the 10% of the whole big thing. So my focus on this would be on this 10%. That what is it that gets used most of the time, and just teach you that in a very friendly way, so that once you understand that, not only that is the thing you're going to use 90% of the time when you later learn more other things, but also this will act as the initial map. So if you have like no idea about data science and you learn these few things and you connect them together to actually build a useful project, now that walkthrough will give you an overview of how does the whole ecosystem work. And once you have that initial map, then any new information, you have some map where you can plug it in. So if you don't understand what I'm saying, just take it easy. The course is beginner friendly. We'll be covering a lot, but it will be very easy to consume. Don't sweat about memorizing anything, taking notes, etc. All will be there for you. You can come back to it anytime you want. So this is just some things I wanted to say before we actually begin the course content. Now, as I said, I wanted to start with what is data science. And I wanted to say that this is what is the modern definition of data science, because data science is still a relatively new term, probably like 10, 12, 15-year-old term. And there is a lot of confusion around it. So I wanted to share some thoughts around that in this very quick section. So first of all, this is how I define data scientists. So data scientists are someone who help solve business problems using data. And when you look at it from that perspective, from this perspective, so data scientists are basically problem solvers. And like every problem solver have some tools. For example, plumbers have plumbing tools to solve plumbing problems. We have data tools. So we are specialized people with the data, and we solve some business problems which have some actual insights. And I really love being a data scientist for a couple of reasons. One, because of this problem-solving lens. We're actually working on some interesting business problems. And then when we solve those problems, then we can clearly see what is the impact on the business. And since this is like more like a problem-solving thing, there is no clearly defined roadmap when you become a data scientist. Okay, do this, then the next step, the next step. Problem solving doesn't work like that. Problem solving looks like you have a problem, you have no clue what will work. You have some approaches in mind based on your prior experience, and then you try some will work, some will not work, and eventually you will come up, hopefully, to a working solution. So this path of discovery and not having a clearly defined roadmap, I think that is what makes data science so interesting. And the other thing is that unlike a lot of other tech jobs where you just do one thing and you do it on a daily basis without seeing what is the impact on the business, with data science you can clearly see what is the outcome on the business for the problem you're trying to solve. So from that perspective, I think this is like very exciting work, and you'll get to see that firsthand when we build our first project, because that is actually a sales data, and you'll be making some actual predictions. And though this data is not used by anyone anymore, but if it was a real store who has the sales data, and you are able to predict who is going to buy which product for how much they'll be spending on it, that is a mind-blowing insight, because then businesses can do a lot of decision making. Okay, what inventory should we be keeping? What should we be promoting to which customers if they want to send some marketing campaigns, etc.? How should they be pricing products based on how most people buy it? So there are a lot of insights which are real life. It's not some theoretical, abstract concepts. Some real life utility of all these insights. So this is how I define data science. Now, there's a lot of debate and confusion about what is data scientist, what is machine learning engineers, and then the new term AI engineers. How are they different? The way I look at it, for most practical cases, you can say they're the same. Even when you look at job postings on LinkedIn, etc., a lot of companies are saying data scientists / machine learning engineer, or they'll say data scientist as the job title. And when you look at the job description, machine learning would be mentioned a lot of times. So it's like very similar. If you want to zoom into it, then the way you can probably define is that data scientists are, the scope of data scientists is very broad. So as a data scientist, we do a lot of things. Machine learning engineers, sometimes in some companies, they are more focused towards model development and deployment. So it's a slightly more specialized role within the same umbrella of data science. And for AI engineers, I think this is still data scientists with some knowledge about large language models, because since the advancement of LLMs and the launch of ChatGPT, a lot of companies, when they say AI, they mean basically ChatGPT version of some LLM. And when they say AI engineer, they basically think AI engineer is someone who is good at using those LLMs like ChatGPT with a programmatic approach. But when you actually deconstruct that, pretty much most companies are not in a position to develop their own LLMs like ChatGPT, and most of them are not even in a position to fine-tune them. So then the role of that AI engineer essentially boils down to prompt engineering, which is basically how do you tell a computer, how do you tell an LLM how to do a certain thing. And if you have ever used ChatGPT, you have written the prompts, and that's basically what prompt engineering is, and something which you can learn in a day. So I think AI engineers, even companies, are a little confused, but when you take a step back, this is basically data scientists who have some knowledge about prompt engineering, which you can learn in a day. So not a rocket science. In a nutshell, pretty much all three of these are very similar. You can consider them the same. The other thing I wanted to highlight is that data science not only is everywhere, it was everywhere. Even before the launch of ChatGPT. I started my data science career in 2015, and even then, AI was on a rise, and it was a big thing. And even if you don't realize, in pretty much all the things you are using, there is AI used. So in your phone, in your laptop, there is AI used. When you go watch YouTube, there is AI which is recommending you content. And I'm forgetting the statistics, but around about 75% of the content watched on YouTube is coming from recommendations. So if there is no that AI, you can imagine what the future of or the trajectory of YouTube would have been. Same goes for Netflix. Most of the content when people open Netflix is based on recommendation. From where does the recommendations come? From AI. And same goes for a lot of other things you use on your daily basis. Amazon recommendations, again AI. When you make a transaction on your bank with your bank, and you get that alert that it might be a fraudulent transaction, there is this AI system behind the scene which is inspecting every single transaction you make. So AI has been everywhere. It might not be visible to you as much as it is with the advancement of LLMs, and you can go to ChatGPT and see that how the AI is actually performing. But AI has been a little bit hidden, but it had been everywhere. And just to demonstrate the power of prediction, I wanted to showcase two studies with you. So let me begin with this AI examining X-rays. So this is 1.5 years ago, to 2023, where when they saw when they given some x-rays to humans to understand what is wrong with that person, and they gave the same x-rays to AI, and the performance of AI was as good as qualified, well-educated doctors. It's the same. And this is 1.5 years ago. Now you can well imagine that the performance of doctors might not increase significantly in the next 10 years, but the performance of AI would definitely increase manifold in the next 10 years. So AI is becoming very, very good. And the study I want to discuss with you about Target. So this is a retail store in the US, and a very big retail store. So in 2013, 12 years ago, they sent some coupons about some baby products to a home where, and it was addressed to a girl, which was a teenage unmarried girl. So when the father of the girl saw that there are some baby coupons sent by Target to his daughter, he was very disturbed, and he basically reached out to Target that why are you sending these baby products to my teenage daughter? And when Target looked at it, they realized that it is based on the data they have. And based on the data they have, it looks like that his daughter is expecting a baby sometime soon. So the father didn't know about it, but Target did, because this was actually true. The girl was pregnant, and Target knew about it based on her spending pattern. So when you carefully collect the data and analyze it, that is sort of the level you can get to. And this demonstrates the power of data and how far you can go with the data analysis. The other thing I want to quickly touch is that there is a lot of fear with the term AI, and pretty much everyone who wants to get into any profession is a little bit reluctant that AI is going to take over that job. Same is true for data science. A lot of people they're a little reluctant that if they start learning data science, it's possible that in sometimes AI will take over, and then no job will be left, and then they will have no future. But I just want to demonstrate that AI is your ally when you are becoming a data scientist, because you will be using the latest advancements in AI to solve business problems. And if there is any transformation going on because of AI, you will be the part of it. And in future, as more AI-related transformations happen, more data scientists are needed. So AI is actually your friend when it comes to data science. You'll be using a lot of AI tools to implement and solve some interesting business problems. As a data scientist, whenever I see any improvement or a new AI tool launched, honestly, that makes my job easier, because now I can make some advanced solutions to the problem which were not very easy to solve previously. So AI is your friend. Don't worry too much about it, that it's going to take over your job. AI is data scientist. So these are both on the same side. And a little bit about the future of data science. And as I said in the beginning, my views on this might be a little bit biased, since I have been part of this industry and I love it. But just looking at the data in a very non-commentary way, I'll let you take away your own thoughts from this. So this is from August 2024. TrueUp is a very reliable data source. And even if you go to the TrueUp and you look at the overall tech job postings, you can see it is declining or have declined a lot in the last 2 years. But when you look at the AI ML related jobs, you can see there is clearly a very positive relationship there. Now this other screenshot, it is coming from Bureau of Labor and Statistics. That is a department in the US, which is supposed to basically take a lot of, they gather numbers and they analyze it and they publish their findings. So the job growth which they are expecting for data science role, this is maybe a year old, is 36%. It is much, much faster than the average, because the average job growth in the US is 4%. Now you compare it against 36%. That is what they see, how much it will grow in the next 10 years. And you're going to go to the same website for for Labor and Statistics. It's a little mouthful to say, but look at the job posting and see what the job growth is. You would hardly come across anything which is 36%. Most of them would be under 10%. There are some which are negative, because in the future they don't see there will be as much jobs needed. But for data science jobs, this is pretty phenomenal. 36% anticipated job growth into the next 10 years. So I won't comment much on this. As I said, I'm a little biased, but this is the data from two very credible data sources. You can verify it on your own. But I think it gives you a very clear picture of what the future looks like. Okay, so now let's quickly go over some housekeeping and educational thing about Python and Google Colab before we actually go into the laptop and start doing the real meaty stuff. So Python on Google Colab, as easy as it gets. Why is that? Because I think Python in itself has been like a very easy programming language to learn. Just like it's like most like very English-like syntax. I've worked in C++, I've worked in Java, and I know some other programming languages too. Nothing comes close in terms of ease of syntax. And then Python, when you run, the only issue with Python or any other programming language would have used to be that you have to install certain things and set up the environments, all of that. When you use Google Colab, all of that pain goes away, and we'll see in a bit. And then Google Colab is adding more and more AI functionalities, which just makes it so much easier. Learning this stack now is at least, I don't know, 100 times easier as it was 10 years ago. When you have to install something and then you'll get errors and then you don't know how to debug. Now everything is on steroids. It is super fun, super easy. You'll see in a minute why I'm saying it. Okay, so why Python? Why I'm not using any other library? Sorry, any other programming language to teach you these? First of all, it is the most popular programming language when it comes to data science, especially. Pretty much every job I've seen, they use Python. And it used to be Python or R, but R has just faded away in the last couple of years. You might be able to find some job where they're still using R, but Python is the thing. That's why when I'm going to teach this, Python is what I'll be focusing on. Second thing, easy to understand and write. As I said, this is probably one of the easiest programming language to learn, because this is one of the easiest programming language to write. Just to give you a taste of what I mean. So if you have to print just one word, hello, in two languages, Java and Python, this is what the code looks like. So this is Java and this is Python. You just want to print a single word, hello, and you can see how much code you have to write. And there are semicolons and there are brackets, and then you have to define string type, declaration of classes. None of that in Python. Just print hello. That's it. So one of the easiest language to learn. The other thing is that it is one of the most supported language when it comes to data science libraries. There are many data science libraries, and every library has a support for certain languages. Python is supported by every single one of them. And if you are wondering, love, what is libraries? And that's maybe when you think of or use the word library, some physical library comes in your mind. So library is sort of similar, but just to explain it in an easy to understand way. So when it comes to coding, there is a very popular concept. It is called DROI. So it is basically do not repeat yourself. So when we are teaching computers, do this. The next time we are trying to say the same thing, we can just ask it, do the whole thing, which we have explained in the past, and it should be able to do it. We don't have to go again and write the code for that. An example is Lego building. For example, if I am teaching a computer how to assemble a car with Lego blocks, then I'll tell you, okay, you take a single block and then you construct it in this way, and then you'll get a tire or maybe an engine. But once that tire is built and I've taught computer how to create that tire, next, when I'm creating the cards, I will not again tell it, okay, go take those Legos and create, this is how you create a tire. I'll just say, okay, create a tire, because I've already taught you how to create a tire. And once I've taught how to create a tires, then for the car, I can tell it, okay, create 4 tires, and it should be able to do it. Once I have tell it how to create a car, because of it assembling first from Legos to Lego blocks to tires, and then now cars, then I can say, okay, I'm designing a street, I need 4 cars. And then I don't have to go and tell, okay, how does a car is built? So the same basically analogy applies here. And it is applicable everywhere. Even if you are doing website design, there are different components which are very reusable. For example, there is a CMS, for example, WordPress, where you can just basically host the content and put everything and manage that content. And once that, for example, WordPress is designed, the next person doesn't have to again think, okay, how I'll be hosting the content and managing it. WordPress is there. You can just use WordPress. Once you have decided on WordPress, then in terms of what the look and feel would be, you can just create one-time theme, and then people can just use that theme. Same goes for gaming. Do you think when people are creating the games, they design every straw of a grass from scratch? No. They're just libraries which, okay, give me grass of this color, and someone has previously created, you can just reuse it. So this makes it much more efficient and powerful. And what happens is that there are some libraries built from the code, and then the next person, instead of creating the whole thing again, they'll just use this library, and then a new library is created. So by this, everything is just made much more efficient. If it's not fully making sense to you, don't worry about it, not very important concept, but just an illustration of how libraries use other libraries. The Pandas library, which we are going to go through today, it was built on top of a NumPy library, which was also like a very elegant library. So in nutshell, when you use libraries, you are leveraging the hard work which other people have already done. And hopefully, when you become very proficient with Python and all these libraries, you'll be creating your own libraries. And then other people can just use that easily. So libraries plus AI is a superpower. Now, why would I say that? If you know what libraries you would be using, you're already doing things from a very high leverage perspective. You already are leveraging someone's years of work. And when you use AI, you can basically ask AI, I want to use this library to solve this problem. Help me solve it. And now you don't even have to learn a lot on how you should be using that library. AI would do the work for you. So if you know these two things, which library is suitable, how do I use it, with the help of AI, you can do pretty much everything without any pain. It will be just so much faster. And there are some libraries we'll be using today. As I said, pandas, which is the SQL, the Excel in Python. And then there is scikit-learn, which is for machine learning, where you teach machines how to predict the future. Cool. So now let's get our hands on the laptops and let me teach you some stuff on how we would be doing some of the interesting actual coding work. Okay, so now I'm on my laptop. So you can just search in Google, what is Google Colab? And this is the first link, welcome to Google Colab. You come here, and I already have some notebooks open, but let's see that you don't have any, and this is the first one which you're seeing. You can create a new notebook if you go to File, New Notebook in Drive, and this will basically create a new notebook for you where you can write the code and you could do all of that analysis. I just wanted to give you an overview of how different things are working within this. So this is the name of the notebook. So I'll just rename it to my first data science project. And just like everything in computers have an extension, the extension for notebooks is IPYNB, which it basically means it is Python notebook. Then you have these cells where you can write the code. For example, I showed you how to print hello. So let's do hello. And then you can do this, enter this plus sign here, or you can use this shortcut, which is Command Enter or Control Enter. So we'll do Command Enter, it runs this cell. Okay, so it is, now you can see the hello gets printed here. It took a while because when you look at it, it was previously connecting, now it is connected. So now you have it working. The good thing about notebooks is that previously, if you have to run the same piece of code, you would have to install some libraries, and then, you have to install some packages basically in your laptop. And with this, everything is set up for you. You can just go there and start writing Python code. It is as easy as it is. And it is using the compute provided from Google, so it is not actually taking resources on your own laptop, which is also important if you do not have like a very high fancy laptop. And from here, you can see that how much RAM it is taking, how much disk space it is taking, and if it is connected or not. And these are the cells where you can actually write the code. Now, if you want to create more cells, you can just press this code button to create a code cell, or you can press this plus text button to create a text cell. This is text. And now I have printed the text here. Similarly, you can do plus code and plus text here as well. It will also create more cells for you to play with. Now, under each text, under each cell, you'll see what the output is for that cell. Now, that is pretty much most of the things you want to know. A little bit more, just in case, just like pretty much every tool has, you have this front, the toolbar on top. You can see what are different options there. You won't be using most of them, so don't worry about it. On the left, you have some things. It will show you how your code is organized, especially if you have different sections. You don't have it right now, so don't worry about it. This is find and replace, typical find and replace you have in any word processor. You can find, for example, where I've written hello, and it'll be able to find it here. This is a little good, maybe at a later stages when you're trying to debug and you're trying to see, okay, how does the value of each variable change over time? This is where you can basically store some of your secrets. For example, I was trying to use Gemini and some other APIs, so I can store their credentials here so that they are not visible, but they are accessible when in the code. And then this is the directory where you can put things, and then you can use that when you are trying to use your code. And this is pretty much most of what you need to know within Google Colab. The good thing about Google Colab is, first of all, you don't have to set up anything. Just go to this colab.research.google.com and create a new notebook. Takes 10 seconds and you are ready to start writing your own code. The other thing about this is that there's a lot of AI support. So for example, here you see that it says start coding or generate with AI. So if I ask it to write a code which prints numbers, let's say odd numbers from 0 to 10, and I enter it, it has written the code. Oops, did I mess up anything? Okay. Okay, it has written the code, but there's some problem. Yeah, now you can see. I have to change a little bit, but the code is not working. So there's a lot of AI support. I'll show you more as we go into it. Now, this is the Google Colab place where we'll be running the code. Now let's look into the libraries we'll be using and also the data set which we'll be using. So the data set which we'll be using is Black Friday sales data, as I said in the intro. So this is the Kaggle website where it's available. I'll share the link with you as well. And here you can see that they have not provided much description, but we can look at different columns and what the different values are. There isn't a lot to cover, but we can quickly see that. And then you can see what are the files available. So they have provided us train and they have provided us test. So this is a very typical scenario when you're trying to do a prediction job. So usually they provide you a train data set so that you can train your machines to make the prediction. And when they're when they're giving you the train data set, they give you the things based on which you will be making the prediction, and they also give you the thing which you're trying to predict. So you will have the actual values. So in this case, we have users information and we have product information. And then there are some features which are related to the user, and then there are some information which is related to the product. For example, for user, we know what is the gender of the user, what is the age of the user, what is their occupation, what is their city category. So they have not mentioned the city, but they have 3 categories, A, B, C. I believe it is could be related to the city size, that if living in a big city or a smaller city. Stay in the current city, how long they have been staying in that city, what is their marital status. I believe 0 means unmarried and 1 means married. And then now this is the product feature. For each product we have what is their product category. And there are 1 to 20 categories. They have hidden it, so we don't know what 1 represents, what 2 represent, and so on. But just for your own understanding, you can think that maybe 1 is cosmetics, and 2 is clothing, and 3 is toys, and so on and so forth. So there is a product category which is assigned to every product. And as with a lot of products, it's possible that one product does not fully belong to just one product, one category. So that is why they have product category 2, and I think there's a product category 3 as well. some examples of this could be, for example, sports clothing. So now, does it go into the sports section or does it go into the clothing section? That's why there is a category 1 and category 2 both true. As you can see, so this, for example, this row has category 1 as well as category 6. But this is the main category. Category 1 is main category, category 6 is secondary category. And category 1 is filled for all the products. Category 2, not so much. So this is the data, and then you have the thing which you're trying to predict is basically how much they would be spending on these products. So at the time of training, you will have that number available, that how much this user spent on this product ID. They have not given per unit price. They have just told that how much they bought for that product. And based on that, we'll train our machines. That's machine learning. And then we'll do some analysis. And this will be exciting. So I just wanted to give you an overview of what is the data set we are looking at. Most of the data sets posted on Kaggle, they are actual data sets. They are from some shops or some stores. When we'll further look into it, you'll see that the prices are a little high. So I believe this data set was originally from India. That is why you see that everyone is spending in thousands. So of course it won't be in the US because people don't go into the stores and spend thousands of dollars for most purchases. So that is like the high level overview of the data set which we'll be using. We'll be using Pandas library for this, and you can get a very good idea of what Pandas is. This is the homepage of the library. This is a book written by one of the author, Wes McKinney, if you want to read it. And it is one of the most stable and most popular libraries for loading the data and then actually looking at it and analyzing it. And then if you want to look at the code, again, going back to the thing where I was trying to say that with libraries, we can leverage someone else's years of effort spending code. For example, if we say, let's see if it downloads, okay, it downloads it. But if we go to Pandas GitHub, we can see the whole code here. So as you can see, it is open source code. A lot of people contributing towards it. 3,600 issues, 92 pull requests. So very active community, a lot of people trying to build that code so that people like us and you, we can use it with an ease. The other library which we'll be using for making machine learning prediction is scikit-learn. So this is scikit-learn. Again, you can try to spend some time on its on the documentation of this, but don't have to do it right now because we'll be looking at both of these libraries in a very easy to consume way. Okay, so one thing I wanted to do when I'm trying to teach you this, let me clean this up. So I'll delete all the texts and code cells which we have created. Now we have a fresh start. This is my first data science project. One thing I wanted to do is that I wanted to show you that how you would do it in Excel. Everything I'm trying to teach you, how you would do it in Excel. So I have this Excel open here, and just to give you a comparison of whatever you're trying to do in Excel, basically you can try to do in Pandas, and how Pandas is basically Python's Excel, but Pandas is much more powerful. So this is Excel, and here let's import Pandas because we want to use Pandas as PD. Now what is this code doing? I just made Pandas a little bit shorter so that later on when I'm addressing it, I don't have to write the whole thing Pandas, just convenient thing. And it's very conventional when it comes to Pandas. People a lot of times address it as PD. So now I have PD pandas data frame here. We have Excel here. Now, if I want to import data or use an existing CSV, how do I do that? So here, I'll say File, Open, and then I can go to Upload. Yeah, Upload. And then I can browse a file. And this is a file I wanted to use here, train.csv. And as you can see, it is getting uploaded. And once it is uploaded, I'll be able to see it here. Now, how do I do it here? Very easy, similar. So you see this browser, this folder directory here, you click here, and you upload, and you upload the same CSV file here. Okay. It's giving me a warning that when the session is over, this file will be deleted. So if I want to preserve this session, I can connect it with my Google Drive so that whatever file I'm using it, they stay there. I don't have to do it here, but you can do it if you want to. Okay, so this is opening here. The file is uploaded. Let's see, why is it taking so much time? But while it's loading, let me come here. And now if I want to see that file, I can do this in this way. I'll say df. So this df is again a very conventional thing to call data frames. So data frame is basically a table. So in pandas, we call it data frames. So that's why df is just a short for data frame. And when you look at here, what is interesting is it already sees that I have imported train.csv and I have imported pandas. So most likely I want to read it. And it has written the code for me almost. If I hit tab and enter, it says no directory data, because there's no data directory. It is just train.csv. So it can make some mistakes. Actually, let's see. So if I ask it to, let's see if it can self-resolve it. So there is this next steps, explain error. So I just clicked on it. Here this thing open up is saying, no such file, suggested changes, verify file path. And now it is intelligent enough to know that it should be only train.csv. So now if I say, okay, let me do train.csv, it works. Okay, so if this is the first time you have seen Python code written, might look a little intimidating, but I try my best to basically explain it in a very easy way. And we won't be writing a lot of code, so don't worry too much. We'll be using libraries, and it's not very difficult. So the first thing we are doing, we imported pandas as PD, just a smaller name, so that because we'll be addressing it again and again, so it becomes easier. And then we are asking pandas, hey pandas, go read this CSV file, and this is the CSV file we have provided. And whenever in Python you see this equal thing, it is basically, it is taking whatever is on the right side and putting the value here on the left side. For example, if I say, okay, a is equal to 1, and I write it. Now 1 is assigned to a, and a is considered a variable. Now if I say, okay, what is a? It is 1. So same thing here. I've asked pandas, read the CSV and put it in df. Now df, if I say, okay, what is df? You see, it has given me a lot of, it has given me the entire data set. And it is saying there are 550,000 rows and there are 12 columns, a lot of data. And the same is happening here. So now this train.csv is opened. We can see the data here. What are the different columns? Same thing we can do here. Very similar. And there is like one-to-one mapping between both things. Okay, so again, an overview. There are some user features. So when we have gender, age, occupation, etc., 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 and then there's some product features. Product category 1, 2, 3. And then we have purchase, how much they bought it for, 8,370, 15,200, blah, blah, blah. And we want to first analyze the data. Second, we want to see that how we can make this machine learn the pattern to predict the purchase so that we can tell in future which customer is most likely to buy which product and how much they're willing to spend on it. Now you might say that you can do it even with the help of machines, because if John bought product A for 5,000 in the past, we can say John will buy product A for 5,000 in the future. But the beauty of this is that what about if John has never bought product B? But if you have analyzed the patterns, you can tell John has propensity to buy product B at this price, or this is how much he would be spending on it. So it helps you give predictions even for the unknown thing. We'll touch more on that. But coming back to what is pandas and how do we use it for the data thing. So the very first thing, we want to look at the data. We can see it here this way as we would see in our Excel. Then there are some nice little things I want you to know. One thing is that since it has like a lot of rows, you can just say df.head, and this will give you 5 records. If you want more, you can define 5, you can say 8, you can say whatever. Let's say if I say 3. So this will give you just the top 3 records. Very easy to see just the top records, even if the data set is huge. So now you see, okay, this is what data df head is. Let me see one thing here. Okay, close this. Cool. The other thing is that you can ask it to describe the data. So df.describe. And here it is giving you a lot of useful insights into the data. You can see that it is telling you what is the count for each of these columns, what is the mean, which is average value, what is the standard deviation, what is the minimum value, 25th percentile, what is the maximum value. So all of that information, which would take you a lot of time to basically collect and understand when you are dealing with Excel, this is just with a single line of command, df.describe, and it gave you all of that. Another sort of similar command is df.info. It'll give you the information about the data frame. So here you can see that it's telling you what is the columns, what is the column index, how many non-null values are there. You can see most of them are not null. The product category 2 and 3 these are the values which have most of the nulls. And what is the value type? So int 64 is basically integers. So integer is something like 64 or 33. These are all integers. Float is something with a fraction. So it will be 64.33 or 22. This is a floating point number. And then object is basically, it could be anything, but most likely it is a string. So for example, this is a string. So in Python, when we are mentioning string, always remember you have to add quotation marks around it. Otherwise, it doesn't know what is it. So if it has quotation marks in it and there's some text, this is a string. And it will represent it here as an object. Some good thing to know. Okay, so these are some very useful things which you can use to basically look at the values of your data frame. One thing, I'm just trying to think what else you would do when you are looking at the data in your Excel. One thing which we very frequently do is we sort the values or based on some columns. For example, based on occupation, I want to sort it. Then I'll say, okay, sort sheet A to Z. I can do that. Okay, now it is sorted. It even took away the column name. Anyway, so here, how would you sort it? Now, this is again, whenever you add these pound signs before anything, it basically means you are adding a comment. So this is your way of telling this Python thing, hey, don't execute it. This is just written by human for other humans, not for the machines to process. So you just ignore it. So and you can see the color changes here to green, which means it's just a text for my own purposes or some other humans. So here, let's see how would I sort the data. For that, again, df. Okay, so the beauty of it is that the moment I wrote this comment, sort the data, you can see what happens in the underlying value. It just guessed it based on my comment, what I want to do, and it wrote the code for that. This is pretty amazing, right? Because otherwise I would have to go into the pandas documentation and I have to find, okay, what do I need to write and what is the correct syntax of it? But here, okay, let me do auto tab means, okay, I accept what you're saying. Let's run. And you can say it has already sorted them by age. Fantastic. Ascending is equal to false, means that it won't be ascending, it will be in a descending order. But if I say true, then it will be a ascending order sort. And you can sort it by different columns as well. For example, if I say, okay, sorted by this guy, stay in the current city years. Done. So now you have it sorted by stay in the current city years. Another quick thing I want to show you, just to give you some tools in terms of how to know what code to write if you get stuck. So let's say I have the sort values, but I don't know what will go in, what are the variables which goes into it, how do I define it? So you just write df.sort values, enter. And now it is giving you the documentation. So it is saying, this is it. These are the parameters it accepts by. There is access, there is ascending, there's blah, blah, blah. These are optional things you can pass on. And then there's more detail. What does by? By means a string, or it could be a list. That is access, ascending, kind, so on and so forth. And then there are examples. So you can look at what is expected. You can look at the examples. You can actually copy paste the examples. df.sort values, I can just copy paste any of that and I use it. So this is a very neat and handy tool if you sort of know what value you want to use, what are the commands you want to use, and you don't know what are the things which you have to pass on into the brackets. This will give you that. So you have df sort values, and let me again, let's try to see if the AI thing helps us complete it. Sort the data by, let's see, purchase. And I come here, again, it has guessed it what I want to write, and it has written the code for me. Let's do that. Okay, so we can see now it is the most people have spent is 23,961. There are 3 purchases, interesting, of the same price. And it looks like they are in the same age bracket, 26 to 35. Very interesting. And it's the same product too, okay, but it's a different person. So this hopefully gives you some idea of how do you do the sorting. You know how to do it in Excel. You can do it pretty much almost with the same ease in Python pandas as well. Now, some of the things which we do in here is that, let's say if I want to filter the records, create a filter, and I want to filter it based on occupation 0. How do I select all of them? Selecting all, clear, okay. So I just want to look at people who have occupation of 1. Now they have sort of codified it, so I don't know what occupation 1 means. Could be software engineer, could be plumber, could be anything. But I just want to look at the data where the occupation is 1. I come here, I apply the filter. Now everything I'm seeing here is 1. Let's see how we can do that in pandas. So again, just to help us a little bit, I'll write the comment what I'm trying to do. Filter the data frame. So we say data frame, just a convention, you should know. Where occupation is 1. Okay, now enter. You see, it has written the code for me, which I can use as is, but I don't, because I want to. Okay, yeah, because I want to teach you how to do it. So the first thing you do is you write the data frame. It's pretty much every time you want to do anything with this data frame, you start with that name of the data frame. Then you add these brackets, and within these brackets, you tell what is the condition. So the condition is that for this data frame, when the column name is occupation, again, it is a string, so we have to pass it in within the quotation marks. Again, if this is looking like little difficult to remember, you don't have to remember. I will give you this exact notebook. I will give you a cheat sheet of both pandas and scikit-learn, which will have these commands as well as some other commands, and it won't be very long. It'll be just like maybe 10-15 commands, and you can just look at it, and if you get lost, you can just try to use it. For now, just try to see that how easy it is to do the same thing which you are trying to do in Excel in pandas, and how pandas is just so much more powerful. Okay, so you define what is a column, and then you say it should be equal to, and the equal would be coming 2 times. Little syntax thing to keep in mind, 1. And here now we see that all of these entries have occupation of 1, and there are 47,000 such records. So same thing which we were trying to do there, we have done here. Okay, one thing which I was not actually planning to teach, but let's say, just sort of consider it as sort of a difficult stretch goal. Let's say if I want to see, give me all the people where occupation is 1 and the marital status is 0. I want to see all the unmarried people who are occupation 1 category. So let me just copy this and do this. So now here I've already defined occupation is 1. I can just copy the same condition and I'll say and then I'll do this, copy again, but this time I'm saying marital status should be 0. Now it will throw an error. Let's see. You see, there's an error. The reason I wanted it to throw an error is that I wanted to show you how to basically debug it. And how actually, let's use AI to debug it. So it throws an error saying the truth value of series is ambiguous. By looking at the error, you won't fully understand what's the problem here. So you ask AI, hey, explain the error. And the good thing about this is that you don't have to go to ChatGPT in a separate terminal and ask it and copy paste the code. It can just do the things right here in the same window. So now it said, these are the suggestions. You have to add and like this, and there should be further parentheses for each condition. And if you want to copy the code, you can just click copy, or if you want to add it into your notebook, you can do it with this. Let me just copy it and then change it here and then run. So now it has applied both these conditions. You can see that it has the occupation of 1 and the marital status of 0. So pretty powerful stuff. And most of the time when you're dealing with Excel, that's what you do. And here with just a handful of commands, might be looking a little difficult to you right now, but it's not difficult. You would be able to do it. So okay, next let's see that if you want to do a group by. Now group by is a little advanced thing, but I want you to know that because it is a very common thing. We don't usually do group bys in Excels because I think it's a little difficult to do. At least I don't remember how to do it, but the main idea behind group by is that you group different kind of people together and then you ask for, okay, what is the common thing about this group? An example, if I say, okay, what is the average purchase of unmarried people? Now here you can do two things. One, you can just apply the filter, and then you can apply the filter to unmarried is equal to 0, and then you can say, okay, what is the average value of the purchase? But then you have to do it one time for 0 value of marital status. Second time you would have to do it marital status is equal to 1. So you have to make some steps here, right? But group by, you can just say, I want to group the people by this category, and I want to give you this statistics. It will make much more sense once we do into the code. Now I won't be doing the same thing into Excel because I think it's still difficult to do there. At least I don't know how to do it. But here it is super simple in Pandas. Okay. So group by, and a little warning, this is somewhat advanced concept, but super easy to learn. That's why I'm teaching you, and it's super powerful. You'll see how, because once you learn this, we'll be able to do a lot of analysis on this data, just like this. Okay, advanced concept. So let's say if we want to know what is the occupation, per occupation, how much people are spending. So I'll say, okay, df again, because I want to process this data set, and then dot group by. And what is the thing I want to group it by? I want to group it by occupation. Exactly, occupation. And when I run it, it says, okay, now you have a grouped by thing. You have to provide the aggregation function. What do you want? I want the mean value of purchase. So for purchase, I want the mean value. Yeah, I got it. So it told me that for occupation 0, the mean value is 9,124. For occupation 1, it is 8,953, and so on. For each occupation, we can see what is the mean value. Now, let's say if I want to sort of plot it, then how can I plot? Actually, let's ask AI to do it. Plot, do a group by occupation, and then plot the what is the name of the purchase. It is using some other library. Okay, using pandas. No, it's still using that other library, which is basically very popular library. But let's say what happens if we add a plot after this. Okay, so it gave us a plot, but it is not the right kind of plot. We wanted it to be a bar chart. So here, again, I want to know how can I add bar. So if you see, it has sort of auto-completed it, kind of bar, but even if it hadn't, we can come here and then we can say kind is equal to bar. Okay. So now we can see that with just one command, it has created a bar chart of grouped by occupation and then what is the average value of purchase. So just to break down things a little bit again, because I think I covered a lot. So how do you do group by? You first of take a data frame. Then, let me do comments, okay. First you create data frame. Once you have created the data frame, second step is you design group by what? Oops. And then you define what is the thing you want to group it by. Once you have grouped it by, then you say which entity you want to look at. So then you define, actually it will be chained together, so it will be like this, and then like this, and then we define, so this is the column to grouped by. So we have a column to group by, and then column to see. So you see, you tell it what column you want to see, and then the last step is aggregation. So here you tell dot aggregation. So in this case, we did mean, but it could be any other aggregation. You can say what is the minimum value. You can say what is the maximum value. You can tell what is the count of people within that bucket. So there are different aggregations which you can apply. You can look up into the documentation. You can ask AI to, but should be very straightforward. And if you look at the pattern here, this is called chaining in pandas, a very important concept, which is you take a data frame, then you apply some transformation on it, and based on the results you apply some more transformation, and then based on that you apply some more transformation. This is chaining. As you can see, let's say if I take this thing here, which we already have it here. Now I can remove this and run it, and it still has something. I can see, okay, what is it if I remove the last part? Let me now remove the mean too. If I remove mean too, where is it? Yeah. Now it is telling me that it is a series group by object. If I remove this, now it is telling me that is again generic series. And if I remove this, then it's telling me this is the entire data frame. So you can remove some components, you can attach them together, and this is called chaining. Again, let me put everything back. And let's say instead of plot, we want to, once we have it, we want to sort it by purchase. So we'll again add sort values. Okay. Ascending is equal to false. Yeah, so now we can see that which occupation has most amount of spent. So this is basically a high level overview of how you use group bias when you are dealing with the data. Now just to make it a little more concrete, let's try to analyze this data with a handful of commands I have told you. We won't be teaching or learning any new commands here. Just a handful of new, just a handful of questions we want to answer using the commands which we have already learned. Okay, so let me list out the questions here. So the one question is, does gender has impact on sales? So do people of different genders spend more or less? Second question I have is that it's very similar. Does marital status has an impact? Do married people buy more, less? Okay. Third question I want is, which product have the highest sales? And lastly, I want to know who bought the most from the store. So which people are basically the most frequent buyer or have spent the most with the store? Okay, so let's take the first one and let's try to answer it. First thing I want to see that when I paste it, how much AI can help me sort of figure it out. But before I do that, you can see that for each gender, I want to understand sales. Whenever I say for each this, there is an opportunity for group by. So I know it will be a group by gender. And so again, looking at here, this is the data frame we are looking at. We only have one, DF. All the data is in the single data frame. Because we want to know for each gender, the column to group by would be gender. Now next we want to see an impact on sales. So the column to see would be price, purchase. And then we want to say, does it have an impact? So in this case, we'll be looking at the average value, right? The mean. So, okay, so it pre-filled it for us. It says, okay, df.group by gender, which is our column to group by. What is the thing we'll be looking at? Purchase, and then the mean value. Awesome. And if we want to plot it, we can plot it too. We can see that males spend more than females. Pretty awesome. Now let's go to the second question. What is the impact on marital status? Again, on sales. Very similar. We want to see for each marital status, how much did they spend? And again, going back to this example, data frame is the data frame we want to use. We want to group by marital status. The column we want to see is, again, purchase, and again, mean value. Let's see if it is able to help us fill that. It does. So we can see, actually, there's not much difference. Unmarried people, let me remove the plot and see. Yeah, very similar. Unmarried people spend a little bit more than married people. Could be by chance. So nothing we can say for sure. Coming to the third question, which is, which products have the highest sales? And again, we want to group by products and we want to look at the sales. In this case, actually, we want to look at the total sales. Yeah, so we want to do a sum. Okay, let's see. Okay, so here it is. Okay, it is doing it a little bit wrong. It is looking at a product category. I mean, we can do it by product. Yeah, let's do it by product category. And instead of the mean, let's do a sum and then do sort. Okay, so we can see product category 1 has total purchases of 191 million, I believe, rupees. So product category 1 is definitely where people are spending a lot of money. Okay. Now the last question is, let me go back to my list of questions. Who bought the most from the store? So let's say here, let me change it slightly. Who bought most frequently from the store? Okay, so in this case, by who I mean a person. So I want person ID. I'll be grouping by person ID. The thing I want to look at is purchases. But most frequently, I want to look at the counts. Let's see if it's able to complete it. User ID, product ID, not product ID, actually purchases. Let me change purchases. And yes, so we can see user ID, this guy has visited the store or bought from store over 1,000 times. A very loyal customer for the store, definitely. Okay, so this is basically how you would use pandas. This is the only library we have used so far in this course, and how you can look at the data, you can draw insights from it, you can play around with it. All this exercise which we did, it has a technical name. It is called exploratory data analysis. This is, or in short, it is called EDA. This is the step when you, on your job, get hand on a new data set. You want to look at what's there, what is in it, what kind of different information is there, and how do one thing relates with the other thing. And you basically do similar exercise. Might look a little intimidating to you because this is the first time you're doing it. But once you look at the cheat sheet, there are like maybe 10 commands which we have used. And these 10 commands you'll be using 90% of the time. If you know how to use these 10 commands, you can pretty much do a lot of things and analyze the data. And you can see how fast it is and how convenient it is. You can just look at it, things the moment I run and enter it, just loads it. Because behind the scene, the implementation of pandas is based on NumPy. NumPy is based on C++. So it is supposed to be very fast, much faster as you can do in Excel. And a lot of functionalities which are very difficult to do in Excel, for example, group by things. So a very powerful, very important tool we have used to basically analyze the data so far. So overall, it is a very powerful tool which you should definitely try to learn and spend some time with it. And with the help of Google Colab and AI, I'm pretty sure it will be very seamless and easy to learn. Also, I'll be providing the cheat sheet of the commands which I think are most frequently used, including the ones I have explained here. So if you just know those maybe 20 commands, you can pretty much do most of the things you want to do. Okay, so now that was the part where we were trying to use pandas to analyze the data of what is already there. Now we want to look into the future. And for that, we need to learn some fundamentals of a machine learning algorithm, which is called linear regression. Again, don't be intimidated. I'll try to make it as easy as possible. And let's go back to the slides. Just wanted to show some theoretical components to you so that you could get a sense of how does it actually work. And then we'll get back to our notebooks to actually show how it gets implemented. Okay, so going back to the slides. So the linear regression is the tool which you can use to predict the future. Very, very powerful tool. And I want to start with this quote that knowledge is telling the past. Anyone who has a knowledge can tell what happened in the past. When you can predict the future, that is where the wisdom lies. That is what the power is. And this is the beauty of these machine learning algorithms, that you can train it on the insights and it can, based on that, predict the future pretty remarkably. It is very good at predicting the future. So just to begin with the introduction of linear regression. If you look at the history of linear regression, it goes into 1700s. Some people even say that Newton had some contribution towards it. But when it actually discovered as a linear regression, this was some work which Sir Francis Galton had done in the 19th century. And the reason this has a word regression in it is because Sir Francis Galton, he was analyzing the impact of parents' height of different animals on their children. And as we already know that um, a taller parent usually has taller children, and a dwarf parent, which is not tall, usually have dwarf children. So there is a very clear correlation. It is a very common sense knowledge, but he was trying to quantify it. And one thing which he observed is that um, generally the outlier parents, for example, very tall parents, their children won't be very tall. They'll be regressing towards the mean. Again, a different concept. You don't have to worry about it. But that's how the word regression got introduced. And because of the work he was doing to quantify the relationship, to make it predictable, that if you know the height of the parent is, I don't know, 5 feet, then what is the most likely height of a children? And you have a number around it. That's the work he was doing. And that's how it started. Now, how do I discover it? It was way before when I became a data scientist. So back in Pakistan, one of my uncles, he wanted to buy a shop. And when he was trying to do some study and looking at other shops which were doing well, there are, of course, some common things observing. So in that market, there were different streets, and pretty much everyone can tell that if you buy a shop in street A, you'll have more sales. In shop B, in line B, there would be less sales. So there is a relationship with that. Then there is a relationship with size of the shop. The bigger the shop, the more sales you would expect. And I was very curious that if a human mind can sort of detect those patterns, then is it able to quantify it and tell that, okay, if I buy a shop in this street of this size, how much would be my estimated sales? And if we can somehow estimate it, then that will be a very powerful ability, because if I know if I buy a shop in this street of this size, I'll be expecting $100,000, maybe not dollars, maybe rupees, of profit. Then knowing that information, I know how much I should be spending or how much I should not be spending. And based on that, I can make some very intelligent decisions. So this is how I discovered it. And I posted this same question on Stack Overflow back then. I don't know, maybe 20 years ago. Or, yeah, I don't remember the year. But then someone pointed me towards linear regression, that you can, if you have the data, you can put it into the linear regression or other machine learning tools, and it can predict to you what is the actual value you would have. And we won't go into much depth of it, but you can develop confidence intervals around it. So you can say, I think the value would be 944, but the confidence interval around it is this. So this is the range. I'm pretty sure the value would be in it, but the most likely value would be around this. So very powerful thing. And this is the first machine learning algorithm which is usually taught. There are a lot of other algorithms, but this is the foundational one. Okay, so how powerful is prediction? I already explained to you. There are a lot of business decisions which you can make based on this information. If you could forecast the cost to acquire a customer would be this much based on the pattern you're seeing, that how much you should be willing to spend on it. A lot of things. Moneyball, very interesting actually movie if you haven't seen it. And it actually demonstrates you the power of analyzing data. This is based on a true story of Oakland Athletics. I used to be in Bay Area for 8 years, and I used to go past that stadium they have in Oakland. And whenever I used to go around it, it will remind me of this movie. That how, using the data, they were able to make very intelligent decisions to who they should recruit in the team, what should be the batting order, and all of other things. And with that, they became from a very bad team to a very good team. So if you have your decisions grounded into data and its forecasting ability, you can do wonders. So I just wanted to preface this section with this opportunities of what you can do. It's countless. Don't spend too much time on this slide. I just wanted to lay it out that the way I'll be explaining this is a problem solution approach. So every time I will try to explain to you the why behind why we have a problem and why we need to solve it. And once you have the problem in mind, then the solution is just very naturally comes. I think that's a very good way to learn new things, especially which seems to be a little daunting. If you know what the problem is, then the solution just clicks like this. So I'll try to explain to you the problem people were facing, and then when I give you a hint about solution, I think it'll make much more sense. So let's look at the first problem. So the problem is that this is just 10 rows of data, and this is for home house size and house price. Now we all know that bigger houses are more expensive, smaller houses are less expensive. So we know the data. Just like in my example, we know that the bigger the shop, the more sales it usually has. So there's this common sense knowledge. But how can we does it actually jump out to us when we look at the data? So this is just 10 records. I would encourage you to look at it and see that by just looking at it, can you tell if there is a relationship, there is no relationship, is it a strong relationship? What is it? And these are just 10 records. What if I have given you 10,000 records? Can you look at it and see that what is the relationship and draw any insights out of it? And this can apply to any problem you're trying to solve. If you have the data, you want to see if there's a relationship or not. The example I gave in my another YouTube video when I was teaching linear regression was ice cream sales data. Now, every ice cream salesman knows that when the temperature is high, there are more ice creams sold. So we know the data. But can we quantify it? Can we use it to predict what would be the ice cream sales? How can we do it? So that's how linear regression actually gets evolved. Okay, so question is, or the problem is, can we analyze if there's a relationship? By looking at the data, it's hard. You might be able to do it, but the solution to this is plotting it. So the moment I plot this, it takes you 1 second to look at this graph. And then you can very clearly tell there's a very strong relationship, right? And this is beautiful because you can very clearly see, okay, generally around 1,000, so this is the square feet and this is the price. So you can tell generally for around 1,000, this is the range. Of prices, and as we go more, we can see that the range goes up. I don't know what's going back and forth. Okay, so that is the first thing which we wanted to establish. Now, the second thing was, now how do we predict the predictions for new sales? So now we know there is a pattern, but let's say if I want to understand what would be the price of a home, which is, let's say here, at 800. This is becoming a little very annoying. So at 800, what would be the price of the home? That's what I want to determine. Because I don't have any existing value here, so how would we do it? Well, the solution to this is that we create a trend line. So you can see that the moment I have a trend line here, I can have a plot at 800. I can line it up here, and then based on this, I can see that maybe this is where the home price would be, somewhere around 180,000. So we can have predictions for the new values once we have drawn the trend line. And these are the steps which linear regression takes. It has the data, then it plots it, basically. then we see that, I mean, behind the scenes you won't plot it. There is some mathematical thing, but I'm trying to help you develop the intuition. So you plot it, then you say, okay, how can I use it to find new values? And this is how you use it. Now, once you have used it to find new values, then the next question is, how do we know if the trend line is correct or not? Because when you look at it, there are many possible trend lines. Maybe someone would have it as I had it in purple, or in red, or in yellow, and there are many more. So how would we know if which trend line is actually the correct one? Now, the solution to that is you aggregate the errors. So what is an error? So wherever you see a difference or distance, in this case of a plot, between the data point and the trend line, for example here, so this is a distance. Wherever you see the distance, then you know that your predictions were off, and then you can basically aggregate all those differences. The way you do it is that you start with the data. So this was the home price and home size, the actual chart we previously saw. And because of this trend line which you have just drawn, you now also have a predicted price. For each square feet, you can have a predicted price. Again, going back to this chart. So for each of these prices which are in the bottom, you can say, okay, for 2,500, what is the price? You go and look at that into the chart. Where does it fall? Maybe somewhere here. And then based on that, you create a predicted price. So now you have a predicted price. Once you have the predicted price, then you can say, okay, this is the actual price in the second column. And then this is the predicted price. And how would you calculate the error? Very simple. You just create a difference between the two. So when the predicted price was 48K and the actual price was 45K, you have about 2.4K, sorry, 24K difference, which is the error. It should not have, in an ideal prediction, there should be no error. But that is an ideal which never happens. So now you have an error. So you can sum up or take a mean of this. But the problem with summing up is that there are some positives, for example, this one, and then there's some negatives. This is negative, this is negative. And when you combine positives and negatives, they basically start canceling out each other. So that is why we have to take one more step, which is we take a mean, we take the absolute value of it. So we basically cancel the positive or negative sign. So everything becomes positive. Even this 72K negative becomes 72K positive. And then from there, you have the absolute errors. And then you can take a mean of it, and you can see the mean value here is 332,648. So this is the error of the line which we have previously seen, this line. Actually, yeah, let me show it here. Yeah, this line. So this is the error of this line. So we can get an error of purple line is if it is 34,000, we can get the error of this yellow line, and then we can get the error of this red line, and so forth. We can keep creating different lines, and we can keep calculating the errors. And any line which has the minimum error, that is our line of best fit. So this is the perfect line we want to use for the prediction. So this is how we calculate the lines. Now, of course, you don't have to like draw all the lines, calculate the numbers. I'm just explaining to you the intuition without any math. There are mathematical formulas which can help you solve the gradient, and there is a closed form solution which you can use to basically drive what the line should be. But you don't have to do it because that is beyond the scope, and you have very good libraries which can help you do it just like this. The other approach is that of iterative, which you try a little bit up and down, and see where it gives you the best fit. Again, computers have a lot of power. They can do it for you within a millisecond. So This is just an intuition of how you find the line which is of best fit. And when you have different lines, which one would you pick? Simple. You calculate mean absolute error, and which one has the least error, you pick that line. Now coming to how do I interpret this line? The one thing which is obvious is that the slope of the line gives you an idea of how strong the correlation is. If the slope is like this means that every time you change your x-axis, for example, house price, there is a big increase into the house value. And it could be a negative slope too. So if it is going like this, which means that if I increase the price of the house, then that will mean lesser price for the house. But mathematically, we basically look at two things. One is intercept. Intercept is that if you extend this line all the way to 0 at this case, which is basically to say that what will happen if a house has 0 square feet in it. Now, of course, it's not possible, but what is sort of the baseline? If there is no area, then what is the price? And this gives you intercept. And in this case, we can see that the intercept is 39,666, which is to say that if the house had 0 area, then what would have been the price? The coefficient here means what is the slope of the line, and it basically communicates that every time there is 1 square foot increase in the size of the house, how much the price of the house would go up. And we can see it is 189. So if you are at 2,500, you add 100 square feet area, you can clearly see that 189 multiplied by 10 or 100, so it will be about 18900 increase in the price. And this is insanely important because by this you have like a very clearly valuable and quantifiable relationship established. Now, if I'm a house owner and I was like, I want to add some rooms to my, or some area to my home, I can clearly say, I can get a good idea of how much it would cost. Let's say if it cost me $500,000. And I can tell, based on this equation, that my home price would go up by $600,000. I should do it. If the house price goes up by $400,000, then I should probably not do it. So you can make very calculated, well-educated decisions once you have quantified the relationship like this. So now the next question is that what happens if there are multiple variables? So we just considered the house size. Now we know there are multiple other factors. For example, number of bedrooms, how old the house is, what is the location. So how can we incorporate that? Because whenever we are trying to plot, a human mind can only look at 2 dimensions or at most 3 dimensions. The moment we go into more dimensions, that is just beyond what we can envision. So in that case, we have to rely on maths and computers. As I said, there are mathematical formulas which can help you solve these, and also there are iterative approach which computers can do. So that's what we have to rely on. And lastly, the main key takeaways from this theory is that you need to have some dependent variables. Dependent variables are things which will help you predict the future. Just a second. And you need to have some of those dependent variables. The other information is that you need to have good data, because if you have just some garbage data, it's garbage in, garbage out. If you have absolutely like a random, useless data, it definitely will not have any good prediction power. Then one thing you might have noticed is that linear regression only takes numerical inputs. It only operates on numbers. So if I have some string thing or I have some text, then it cannot process it. I have to convert it into numbers because it can only use numbers. The other thing is that null values create a problem. So when we just have information about house size and house price, if we do not have house size, then we can just ignore it because that row is not adding any value. But in a lot of cases, we cannot discard because there's some other information available. For example, if I have the house number of bedrooms, what is the build year, all of that information, and just the house size is missing, then I might not just delete the entire row. So we have to figure out how to basically fill in the null values. And then lastly, even if we have data where there are a lot of columns and a lot of things available, we only pass in useful information. And the useful information is what we think is going to have an impact on the predictive power of what we are trying to predict. Okay, so with that, I think you now have a good idea of what linear regression is. So let's go back to our Google Colab and see how we can use scikit-learn library to actually make some predictions and use linear regression. It will be much easier with the help of computers, how you'll see it in a bit. Okay, so we are back to our Google Colab. Just let me make sure that session is still working. So this means that this is working, but let me just quickly print 2. Okay, it is working. Awesome. So now the first thing before I feed the data into my linear regression thing is I have to do a couple of things. First thing is, let me write it here. Let me actually write a text cell. Okay, pre-processing steps. So pretty much every time you want to use a machine learning algorithm, there are some pre-processing steps which you would have to take. And these steps, they help you clean up the data so that there are no null values. You only keep in which is useful. So all of that stuff you have to do just if you want to feed the data into the machine learning algorithm. First thing is that we have to deal with the null values. As I said, it cannot have any null values. Second thing which we have to do is we have to just looking at my notes. We have to deal with the non-numerical. So this is huge. For the non-numerical columns, we have to convert them into numerical columns somehow. The third thing which we have to do is that there are some extra columns. We have to drop them. And then we have to split the data, train test split. What is it? I'll come to it in a second. Okay, so these are the pre-processing steps which we have to take. So let's begin with the first one. We want to make sure that there are no null values. And if there are null values, we sort of somehow fill them. So let's do, if you remember, df.info. Once we do that, it will give us a non-null count. So we know that in total there are 550,000 records, but when we look at the non-null count, this is the same as total value, so it means all of them are filled. All of them are filled. It's only category 2 and 3 which have some null values, and we know why, because sometimes product just has category 1 and there's no category 2 and 3. So what we are going to use is we are going to select that column and we are going to ask pandas to fill those null values. How? Let's see. Let's ask AI to do it. Okay. In the df data frame, fill the null values in product category 2 with, so we have to come up with some null values which we can distinguish that we know that this value is basically null, but it has to be a number. So let me just say -1, because I know that the actual values are between 1 and 20. So if whenever I see -1, I know it will just basically a placeholder. Okay, so let's see if it is able to generate the code for this. Okay, so it has done this. We already have it, so it doesn't have to like re-import it. But yes, this. So we start with the data frame. We tell what column we want to do. We say fill NA, fill null values with this. So it will fill every null value with -1, and in place is equal to true means that within the data frame, just make some changes. You don't have to assign it to another variable on the left-hand side. Let's do it. Okay, it did it, but it said in future versions you have to do it differently. And let me do the same thing for category 3. Awesome. Now let's look at df.info and see if there's still any nulls. Okay, now all of them have the non-null count of 550,068, which means we do not have any null values. So we have successfully completed the first step in the pre-processing, which was deal with null values. Second thing, the non-numerical columns. So this is very important. Non-numerical columns. So again, from this info, we can see that product ID, gender, age, city category, stay in the current years. These are, wherever I see the D type is object, these are string. And I have to convert it to numbers. So let's look at, so product ID, user ID and product ID, this is the information we do not need because we want to discern the patterns of this kind of a user and this kind of a product and want to make prediction based on that. For each specific product we don't want. So these two columns will be deleting. So I'm not worried about that. Let's see why age is, why gender is, because yeah, I think that's understandable. So when you have gender, again, it is auto-completing the code, but this is a very interesting or useful command, unique. So if you just have a column name and then you add unique to it, it gives you all the unique values, all the distinct values which are available there. So you can see there are two distinct values. One is female and the other one is male. Okay, so I'm going to do a little bit of slightly advanced pandas, a bit of morning, but you can copy paste it. You don't have to fully understand it. Basically what I'm going to do is I'm going to tell pandas wherever you see F, you put 0, and wherever you put M, you put 1. Or it could go the other way around. It could be any other number besides 0 and 1. It could be 99 and 100. But as long as I have two distinct numerical representations so that I could feed it into the machine, it will be able to detect the pattern. Even if I say 99 and 100, it'll say, okay, whenever it is 99, there are more sales. Whenever it is 100, there's less sales, or whatever. It will be able to discern the patterns. Okay, so the code, advanced code, which I'm going to write is again, so I want since it is on the left side, you can see that I'm assigning it to this. And the Google Colab is just so smart. It has basically read my mind. And it has written the code which I was planning to write. Very smart, very good. So I'm saying, okay, on the gender, apply this map, this mapping function, that wherever you see F, you do 0. Wherever you see M, you do 1. And when we do that, and again, let's look at df. Okay, so you see now the gender, it has all 0s and 1s. Pretty amazing. Now I want to do, what is the next one? Now we have age. Okay, so let me first see within the age, what are the unique values? Okay, so in the age, we have 0 to 17, 55 plus. So I want to apply the transformation here too. And I want it to apply 0, 1, 2, 3 in a order where it makes sense. So 0 to 17 would be 0. What is the next group? 18 to 25. It will be 1, then 26 to, and you get a sense. Okay, so df age, again map, equal to, and look at this. This is just amazing. It has discerned the pattern. It has written the code. I don't know why it's written just half the code. Okay, so 51 to 55 is 5, and then 55 of this, it will be 6, and yes, yeah, that's the code we wanted to write. Absolutely. Okay, again, just double check df, and we can see that age is again 0, 1, 2. Awesome. What is the next one? So we have taken care of gender, we have taken care of age. Now we have city category and stay in the current year. So let's look at city category. Okay, yep. What is it? Cities category has U and I, Q, Q, U, E. Yeah, so it has A, C, and B. So I'm going to again map. I'll say A is 0, B is 1, and C is 2. City category equal to yes. So it has guessed it pretty correctly. Dot map A0, B1, C2. This is amazing. Now lastly, let's do it for stay in years. Okay, so let's see what are the unique values here. It should already be numeric. Unique. Oh, because there is this 4 plus, that is why it is having that issue. No problem. We'll again do the same thing. City current year, city current year. Actually, let's see if it can help us autocomplete that. Yes, it does. Yeah, it does. Awesome. Let's verify. Now we have all numerical data, right? Yes, let's do df.info one more time. And we can see all of them are int or float. The only thing which is still object is product ID. That is fine because we were going to delete it anyway. So how do we delete user ID and product ID? We do df, and then we drop, and then we do what is the column we want to drop, and is it a row or a column? So since it's a column, the access would be 1. In place is equal to true because we don't have to assign it to something. It will be happening within the data frame itself. Done. Same goes for user product ID. Sorry. Awesome. Now let's look at the data. So now we have all numerical, just useful features. We have done most of the pre-processing which is needed to complete this step. Let me close this value thing. Now the last thing which I want to do here is I want to do a train test split. Now, why do we do train test splits? The reason we do them, the reason we do split the data between train and test is that we want to train our model on some data set, and before we do that, we want to keep some data set on the side so that once our model is trained on the trained data set, we can see how well it is doing on the test data set, which we have kept on the side from the very beginning. So very critical that we put some data on the side so that we could test it once the model is trained. Because if you do not do that, then you train the model on all the data you have. And where do you test it? You take a sample of that test set, and then you test. You take a sample of that train set, and then you test it against it. The problem with that approach is that data machine has already seen. So if it has seen a data, it will be very good at it, most likely. So you don't want the model to cheat. We want it to be good enough that it could deliver good predictions on the data it has not seen yet. So this is what we'll try to do. Again, we divide the data into train and test. Train we use for training purposes. Once it is trained, then we see how well it is doing on the test set. Now, of course, dividing it into randomly sampled data It will take some time, but the good thing is that now we are at a stage that we are going to use scikit-learn, which has all these functionalities baked into it. So with a single line, you'll be able to split it. Okay, okay. Honestly, it is so good. I'm thinking maybe when I'm speaking, it just guesses my mind, and so I'll say from sklearn, and it is saying train test split. It has already written it. So good. Let's see. Okay, so now we have imported this functionality. Let's ask generative AI. Okay, train test split the DF. Okay, pretty good. So it is taking a couple of steps. Let me explain, because this is exact code I wanted to write. I'm taking the data frame DF. This is my main data frame, which I have now cleaned it up. It only has useful columns, etc. I'm dropping the purchase, the target value from the X set. So I'm basically dividing the data into two things. One is, these are called predictors. So things you want to use to predict the value you want to predict. So these are the features in X where what are the things we'll be using to predict, and Y is what we are going to predict. Let me add a little comment. Features which will help us predict what we want to predict. So we have dropped purchase from X and kept everything else as is. So this is our X. And Y is that what we want to predict. So this is DF, but we are just keeping one column, which is purchase. That is what we want to predict. And then we are trying to split it into 4 pieces. Let's look at this. So train test split is what we imported. X is the features which we are trying to use. So this includes here some user-related features, their age, their gender, etc. And Y is the purchase. How much do they spend? And then we are saying the test size would be 0.2 or 20%. So we can increase the test size, but 20% seems reasonable. So 80% of the data will be using, most of the data, 80% will be using to train the model. 20% will be keeping it on the side. So this is, once we have trained the model, we'll see how good it does on the 20% which it has not seen. Random state, very optional. It is generally used because train test split, it will randomly assign data to the train set and test set. And if you have assigned the random seed of 42, every time you do it, it will do the assignment in the same way. So if I'm doing it, you want to do it on your computer, as long as the data is the same and the seed is the same, the randomly created train and test set would be the same. So this is for reproducibility, totally optional. I can just remove it or keep it, doesn't matter. So what is the output of this? So it gives us 4 outputs. We give it 2 inputs. We have X and Y, and gives us 2 outputs. One is X train, and then we have X test. So it further divided the X into 2, train and test. And it further divided the Y into train and test. So now we have 4 things. Awesome. So now we have computed all the steps which were needed to do the actual thing of linear regression. So we have dropped the unnecessary columns of product ID and user ID. We have converted everything into numeric values. We have dropped the null values, and we have did the train and test splits. So all of that is done, ready for linear regression. And you already know the theory behind it, at least the intuition. So the intuition took maybe 20 minutes to explain. This will take 2 minutes to implement. This is the power of libraries. Okay, linear regression. Okay, so how do we do that? Well, again, we go back to this library, scikit-learn, which is our new friend, and we'll try to import linear regression. Okay, sklearn, import linear regression. So it has guessed it from my previous comment that I want to use linear regression. Pretty cool. And how do I use linear regression? So this is my model. Okay. So first of all, I am telling that my model will be linear regression. So my model is equal to linear regression, and please don't forget to add this parenthesis. Once I have defined the model, then I say, okay, model dot fit, which is you're going to get trained, you're going to get fit on this data, which is X train and Y train. So fit is basically train. So you're training the data on X train and Y train. So X train again is my features, for example, the age of the user, the gender of the user, what was the product category 1, etc. The Y train is what was the purchase value. Now, when you hit this command, it will do all the steps, not the plotting steps, but all the steps which I explained to you about linear regression. A lot of steps. And this, as you can see, let's see what's the size of the data. Okay. So it has 440,000 records, a lot of records. What I explained to you in PowerPoint, it was 10 records. This is 440,000 records. So let's see how much time it will take. Actually, I can print time if I add this above the cell. Let's see. So it took 181 milliseconds to compute this. So basically 1/5 of a second on 440,000 records. This is how powerful it is. And the model is trained now. You can use it to make predictions. That is what we are going to do next. So now we want to basically look at the coefficients of the model. So let me just say, what are the coefficients? And yeah, let's look at the coefficients for now for each column in X train. Okay. All this code we have previously written, so we don't need that. Okay, let's try this. Yes. So, and let's see what is the intercept. Actually, you can do it yourself. So the model is what is get trained. Model is our main linear regression model. So if I go in model and I do dot, you can see that it is all giving me all the options which I can use to know more about it or use it in future. I can use it to make predictions using predict. There are a lot of other things, and I can get the intercept, which is the thing I wanted. Okay. So we know that if the intercept basically means where everything is 0 and the line is meeting where the x value is 0. So intercept here it means that when everything else is 0, the base value of purchase is 9,627 rupees, I believe. So this is the base value. But how does it change for gender, age, etc.? So for gender, when we go from 0 to 1, I believe 0 was female. So from female to male, there is a 475 rupee increase. For age, when we go from one bracket to another, every bracket was about 8 to 10 years. When we go from one age bracket to another, the price increases by 105 rupees. And it is consistently increasing, which means that older people, they buy more. And gender is telling us that males buy much more than females. Occupation, assuming that there is some kind of relationship between ABC, there is a slight change, not much, 5 rupees, I won't worry too much about it. City category has an impact. So as we go from A to B and then B to C, which we represented as 0, 1, 2, 3, there is a 313 rupees impact for that change. Current stay in city Very slight, 7.93 rupees, not much. Marital status has a negative impact. So let's see what our marital status thing was. Actually, we don't know. But if 0 is unmarried and 1 is married, which means that as we go from 0 to 1, we're from unmarried to married, there's a negative trend in purchase, which means married people spend less. Interesting. Then product category, again, we don't know the name of the product categories, but certain product categories have certain trends. But this is what the model has learned. And these are all very useful insights, which we can then use to make predictions. So let's get to that. Okay, so now we want the same model, which we have used here to make the predictions. Okay, where is it? Let me ask the generator. Make predictions on X test. Okay, so it's saying, okay, we take the test X set, we use the same model which we have trained, and then we are going to use the prediction, and we're going to put it into ypred. So now in ypred, let me add some more. So ypred has predictions for test dataset, and ytest has actual values for test dataset, and the values are predictions. This is basically sales predictions. What was the column name? Purchase. And this is actual purchase values for the same rows. So now we can compare it against each other and see how much is the delta between both. Okay. Compare ypred and ytest. And we can see it is using numpy. Okay, no. Okay, one thing also we can use for the model is that we can see how good our that thing was. Mean absolute error. So MAE for the model. It has to calculate. I believe there is a way to do it. Okay, so yeah, let's do it this way. So the absolute error difference is 3,500 rupees. So on average, our model was off by 3,500 rupees in prediction. It is, I don't know if it's good or bad, but considering that most of the purchases, so let's see what is the average value within the purchase. So what train, and let me do np.mean. So the average value of the order is 9,000 and our is a little bit off. Okay, now let's do side-by-side comparison of ypred and ytest. So we want to look at them side by side to see how much our predictions were doing. And let's do this. So for each row, you can see where the actual value was 19,000, it predicted 13,000. Where the actual value was 15,000, it predicted 12,000. Where the value was 7,000, it predicted 7,000. Where it was predicted value, actual value was 15,000, it predicted 12,000. So you can see there is a little bit of difference, but it is capturing the variability. And the good thing about this is that using that, there are a lot of insights which this store can get. They can know which customer is going to spend money on which kind of product. And even if you have a new product As long as you assign it to those categories, you can get the predictions. Even if you have a new customer, as long as you are able to get that information about gender and age and marital status and all that, you'll be able to get the predictions. And based on that, you can say which customer have interest in what kind of product, how much they are expected to spend in that, and in which product they would not be interested in spending, in which product they'll be spending more money. And then you can send targeted marketing campaigns to them. You can offer them some discount coupons for the products which they'll be actually interested in buying. So there are just so many use cases where you can leverage these findings. And this entire walkthrough is not restricted to the same thing. To this particular use case, you can do the same thing for any other use case you have in mind. You can use the same findings to predict the house prices. There are just so many things where you can apply. And hopefully, as we are concluding this course, you get to know different tools within the Python and data science gambit, including pandas, scikit-learn, and how can you effectively run them on Google Colab with no setup required, and how can you basically use AI help to write everything. Even the thing I wanted to write, I had in mind, but it is just so good that I'm getting so used to using it. So you don't have to memorize a lot of things. And I hope I have delivered on the promise of keeping this entire thing very easy to understand. And I've tried my best to explain everything I'm saying and everything I'm showing to you so that you don't run into issues when you're looking at it. But yeah, that's all for this course. If you want to experiment more on Kaggle, from where we got this prediction, Black Friday sales data, there are many other data sets. You can play around with it. You can find notebooks of people who are trying to implement different things on Kaggle. Kaggle is a gold mine if you want to learn data science. There are a lot of data sets. People are experimenting a lot of things. You can download any of these in Google Colab and try to experiment the stuff here yourself. And if you want like a next step sort of challenging assignment, look into that let's say if try to find a data where the thing you want to predict is not a number. For example, here we're trying to predict the number of what the purchase number would be. The other example I gave you is house price. But what about if I want to predict if someone is going to buy it or not? So binary outcome. Is it going to happen or not? So try to find that kind of data set and see if you can use the same steps which I've explained here and try to do it with the help of AI. A small tip which I'll give for that is that linear regression you won't be able to use it there because it is built for continuous numeric value output type. So if you have a binary outcome, then there is a sister algorithm, logistic regression, which you can use. It is very similar in theory, a little slightly different, but that is the machine learning model you'll use if you want to make prediction about a binary outcome. But overall, if you like the content of this course, please let me know in the comments. I would definitely love to get some feedback. Also, if there are some other things you want me to explain, let me know. Otherwise, whatever I think is useful, I keep sharing on my YouTube channel. If you haven't looked at the content there or subscribed, please do. That really helps me keep going. Thank you so much and all the best for your future journey into data science.